everyone, it's Gladys, and today on Work With Me, we'll be going over 4338 Sheriff Road Northeast in Washington, D.C. After getting a bit of information from the client, this project needed a bit of modifications as far as designs and calculations. It took us 2 hours to do this design. It's only because we had to cross-reference a lot of information from the design to the plans itself. So let's engineer something. Okay, so let's get into it. Here, we're just working on the site plan that's going to be extracted itself. So here, we're looking at the design. We're seeing that most of the grading goes from the back of the site to the front. Even though the parking area needs to be treated itself, we don't need this much pavement. So right now, we're working through the design. We're thinking through it. If we have a parking area, that area needs to be treated. So permeable pavement is a natural option. But looking at the grading here, we're cutting into the pavement that we did have beforehand. So we're going to reduce that permeable pavement slightly. See that we're outside, structure roots around the tree. So then we'll also notate that. Let's move around. Here I'm changing this into an asphalt. I added asphalt on the legend, and I'm adding here as asphalt. So I'm still considering making all of this permeable pavement at this time. But this is grassy area, so this needs to be filled in order for us to cross here and then park in that location. Here we're just adding topography based off this being a grassy area, and also assume that since this is grassy, this is also grassy. So that means all this elevation is going to be changed. There is a small divvy here where it is estimating the elevation. See here it says 4.23. This one's 3.96. We use analyze to calculate the slope, which is about 6%. And the biggest reason why that slope is about 6%, wish I can just take this away. It's not gonna go away. I don't know how to make this go away. It's because there's something there that makes this elevation not as smooth. So that's why we come in, we have to now smooth it out. This is a grassy area now, so now there's a bit of hole here. When we have the 2% slope or less, but here it goes straight down to 6%. That's showing us there's a hole there, or there's something that's making this not as smooth, and this isn't natural. So when we add the pavement, we're gonna have to smooth that out. You'll see that here, if you follow it, this is not consistent with the rest of the site. Then a smoothing tool, and you can see here that there is following this line, this because of contour line, how it's not going completely straight, and it's not consistent with the other contours that you see around it. So that's showing that there is a bit of a hole there, or some type of issue that makes this area not as smooth. So that's just a little bit of reading of how the site is actually looking in person if you don't have pictures available. So you see that. And you also see on this side how it's smooth, and it's smooth here as well. So that's showing, again, that there's a hole in that area. We're just making it consistent. So ignore that hole and then smooth it out, because we are adding pavement into this area. We did a slope as this way. We can't grade into their site, so we have to catch the elevation here and bring it down here. It is possible that it would be in that area as well, but unless the neighbors give us a permission to smooth it out on their property. Again, we're adding elevation points all around, and we're making sure that we are following a consistent pattern. We decided that this slope is going to be 2.45, and that's just basically following what makes the most sense for this site. And here we're looking at the site and making decisions. I think at this point is where I looked at the site and said, this doesn't make sense for this area here to be what it is. So here, and also another thing is we don't want the water just flowing into the face of the building or into the building. So now we're grading it in such a way so to make sure that water is flowing away from the building as much as possible. And not flowing away from the building, it's not rushing to the face of the building, because I'm pretty sure there's going to be a door back here. Adjusting the elevations based off what we have here. So if we have a spot elevation here, we have to put one here, and it's best to just put one on every corner of a structure. Now we're finding a way to make this slopes consistent all the way down. First we're experimenting with 5%, and we just keep looking at the site until we find a slope that makes the most sense and is most consistent. Again, having elevations at every corner. This property, we added this elevation at using a low plot layer and putting it on both sides so that we can figure out what's the cross slope of this site so that we can put elevation markers on each corner of the lot. So the final design is we put asphalt in the back of the lot, change this to permeable pavement, make this a walkway on this side, make this a walkway on this side as well, and here have this grassy area. We did have green roof on this top of the house, but then we found out the owner has a solar company. They didn't really want green roof. They just thought it would help meet storm management requirements. But permeable pavement would be preferred because this is a vehicle accessible area that needs to be treated. So it might as well be treated with this permeable pavement on the ground level, and they can have solar all throughout the roof. And to show you that the calculations work, there's certain internal calculations that we use in-house. The permitting agency has their own Excel sheet that is pretty good tool use as well. I just like using this one just because it shows me more specific information that I want to know on the site myself, as opposed to just meeting compliance alone. So this is not really for sure what it's going to be at the end. So we need to wait for the infiltration results to get a better gauge of this calculation afterwards. We are actually having a surplus for the storm management requirement because we're only required to treat 473. We are exceeding that with having 636, and it's good to exceed it. The reason being because a lot of the times in the field, the contractor will under install, and then you'll have an issue with as-built later where you have to make up the requirements some other way. So we like to over design so that if anything happens in the field, there's enough to make up for that issue itself. Okay, so we got through that project, and we sent off a request for the client to do a geotech report for the permeable pavement. We also requesting the solar layout from the client as well. And just really excited for this project to move forward so that we can submit it soon to the permitting agencies. So exciting things are happening, and subscribe. See you next time, and remember to somehow follow our other series to follow how other projects are moving forward as well. So bye.